So side angle side similarity. We had side angle side congruence. We also have side angle side similarity. So if you have an angle of one triangle, it's congruent to the angle of another, and if the lengths of the sides are proportional, not congruent, but proportional. So two triangles. Okay. If these angles here are congruent, and then I'm just going to do these are in proportion, right? Because I'm multiplying times 2 times 2. So if you have proportional sides and a congruent angle, you have similarity. Side, side, side similarity. If all of the sides are proportional, then you have similarity. So again, I'm going to use 2's just because that's easier. So each of these, if I put them in a fraction, would equal 1/2. So those are proportional. Proportional, if we put the sides, that reduces to 1/2. This also reduces to 1/2.
Oh,
This
okay.
is true. Those are in proportion. Same thing here. If we have 3 sides and we say all of the sides are proportional, these all reduce to 1/2. So all of the fractions of the corresponding sides are equivalent. That means the sides are in proportion. Does that make sense now?
Mhm.
Okay. Okay. Next, okay, so we have side angle side and side 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 similarity theorems. Okay, so we need to determine if these triangles are similar. Okay, so here's what I do. I have the large triangle, right? That's this big triangle here. So if I just take the large triangle, I have an angle, a 3 and a 4. And then I have this small triangle. I have an angle and a 1.5 and a 2. Okay, my angles have already been marked as congruent. So now I just need to see if my sides are in proportion. So I'm going to set up a proportion. Okay, 1.5 and 3 reduces to 1/2, and 2 and 4 reduces to 1/2. Those are equal, so yes, by side angle side. Oh, which was this picture right here.
That is wrong.
Yes, I did not need to draw this because I had already done so. See that? Isn't that prettier than mine? Okay. Side, side, side similarity. We have 3 sides, right? So let's look at corresponding. 12 and 8 go together. This 6 and this 4 go together. And then this 10 and this 6 go together, based on just the direction that the triangles are pointing. So I need to set up fractions. And I chose to do small over large for all 3. You could do large over small for all 3, but you just have to make sure that the small is all on the top or all on the bottom. And now I'm going to reduce each of these. These will both divide by 2. These will both divide by 4. And these will both divide by 2. These 2 are equal, but these 2 are not. So this is no. These are not similar triangles. They look similar just on first you know, just looking at them at first, but because the proportions are not equal, they're not similar. Okay, so we are being told that these are similar. So we're going to find x and y. It's the same as we were doing in benchmark 27. So we've got this side goes with this side, this with this, and this with this. Okay, so any question on how we separate the triangles? Okay, so again, we had these two together, these two together, and these two together. So we need to set up proportions to solve. I have 24 and 32. So 24 over 32 is equal to x over 24. I'm going to go ahead and reduce 24 and 32 because those will both divide by 8. Okay, cross multiply. And I get 4x is equal to 72. Divide by 4. And x is equal to 18. Okay, for y, same proportion. I have 30 over 30 plus y. I'm going to reduce. Cross multiply. And I get 90 plus 3y is equal to 120. So 3y is equal to 30. So y is equal to 10. Some more practice. Now this triangle, do you see how it's just flipped over, rotated around? So we start looking, starting with the short side. This short side, that's the short side. And then from there, we can see that x and 6 go together, and then 15 and 7.5. So I'll set up my proportion. 7.5 over 15 is equal to, say, 6 over x. So 7.5x is equal to 90, I believe. Let me double check that. 90. So x is equal to 12. And then I'll use the same proportion, 7.5 over 15, and I'll do y over 9. So I get 15y is equal to 67.5. And then divide both sides by 15, and you get y is 4.5. No. Alright, so for B, we have the two triangles together, so we need to separate them. So we will do large triangle and small triangle. And we have this angle here that's congruent. This is 12. We have 4 plus 12, so that's 16, and this is y plus 15. And then for the small triangle, we have x, 12, and 15. And x are in the same position, 16 and this 12 are in the same position, and y plus 15 and 15 are in the same position. So I'm going to use 12 over 16 is equal to x over 12. I can reduce this to 3/4. So I have 4x is equal to 36, so x is equal to 9. Same proportion for my y's. I can reduce that. So 4 times 15 is 60. And then 3 times y plus 5 is 3y plus 15. So 3y is equal to 45, so y is equal to 15.
Right, you're right.
Yes, you're right. I made a mistake.
Something ain't right.
I didn't. No. So here's what happened. When I carried my y plus 5 down, or 15 down, do you see what I did? I dropped the 1. And so I wrote y plus 5 instead of y plus 15. So then when I multiplied, I got 15 instead of 45. So, see, dropping off numbers is bad. So what I did, so I dropped that 1. So then I said this was 15. So then I said that was 45. So this is 15, which makes this 45, which makes this 15, which makes this 5. Yeah. So thank you for catching that.
This is just not working. I did it both ways.
No, I dropped that 1 right there. So, alrighty then. Next,
Did you record that?
I did.
With the right answer?
Mm-hmm. Big triangle, ugly
Wow.
triangle. Let's make it a pretty triangle. Big triangle, little triangle. And we're going to say these are 90 degrees. On my big triangle, I have x plus 15, 24, and then 9 plus 9, so that's 18. And then for my small, I have 15, y, and 9. Y and 24 go together, 9 and 18 go together, 15 and x plus 15 go together. Now, we've been solving them proportionally, right? But I want to show you something. If you get a blaringly obvious, what is the difference between a 9 and an 18? 2. These are always multiplied, by the way. Proportions are multiplication. If you can see that 9 to 18 means you multiply by 2, or here from 18 to 9 you divide by 2, you don't have to set up a proportion necessarily. If y is, or sorry, if this side is 24, what would y be? 12. And we can double check that real quick, just with our proportion that reduces. So I get 2y equals 24. Okay, so now we know that's going to work. Well, what's 15 is going to turn into x plus 15. What would x plus 15 be? 30. So what's x? 15. So if you can see very easily, to turn this into this, you multiply by 2. Or divide by 2, or whichever way you want to look at it. If you can see that there's a single whole number multiple or divisor to go from one to the other, you can just use that fact. And last, we have the triangle that needs to be rotated. Okay, so I have a large triangle and a small triangle. In my large triangle, this is my 90-degree angle, so in my small triangle, I want to make that my 90-degree angle also. I label my large triangle, and now I look at my small triangle, right? The 90-degree angle is here, so I have a short leg and a long leg. Short leg, long leg. So my short leg is X, my long leg is 12, and the side that's left over is Y. Now I have two Y's, which means I have to solve for Y first in order to find X, because X and this Y correspond. Oh my. I have two X's also. Hold on one second. Okay, so this isn't solvable because X goes over Y, 12 goes over 20, and Y goes over X plus 16. There's no way to set this up. Well, I guess we could do a system of equations. We'd have to do a system of equations to solve this. So, because I have two variables, two unknowns, two equations. So we could do 20x minus 12y equals 0. And then negative 12x plus 20y equals 192. Nope, not solvable. Here's why I say it's not solvable, because if I multiply this by, let's say, 12, and this by 20, so that my x's will cancel out. Oh wait, no, that works, okay. $3,840. So these cancel, right? And I get 256y is equal to 3,840. Which gives me y equals 15. Which I can then take and plug into here. So I get 20x is equal to 12 times 15. So 20x is equal to 180, so x is equal to 9. Are they similar? We have vertical angles, correct? So these are congruent. Now here's when you have vertical angle triangles, opposite sides. Should be. No, wait, maybe not. Hold on. Short, nope, not. sorry, see how this is short and this is short and this is long and this is long? So same sides. So 1 goes with 1.6 and 1.5 goes with 2.4 because this is the long side, this is the long side, short side, short side. So I need to set these up into proportions and see if they're equal. Now this one, they don't easily reduce, do they? So another way to tell if proportions are equal is cross multiply. So 1 times 2.4 gives me 2.4, and then 1.5 times 1.6 gives me 2.4. If these numbers are equal, the products are equal, then the proportions are equal. So yes, similar, side angle side. If you did the cross multiplication and you got two numbers that are not equal, then they're not proportionate.